Okay, so for 32.4, so this video we're going to talk about the electrolytic setup that will have all universal indicators adding into the electrolyte, and we're going to have a look, okay, how the color change around the electrode. But before we move on, okay, we just want to have a remarks for the last videos. So if you remember this Hoffman voltmeter, okay, we're going to have a over equations having the water decompose and they give out hydrogen and oxygen in process. Okay, because this one is an electrolysis of water, okay, giving hydrogen and oxygen. Then what is the purpose of adding sulfuric acid? That point, okay, you have to remember. Okay, the function of adding sulfuric acid is to increase the electrical conductivity of water. Because you have to know that water actually is a covalent compound and it is not really a good conductor. Okay, indeed, actually, it's a poor electrical conductor. So if you just have pure water, distilled water, then the electrical conductivity of it is not very high. That's why we have to add sulfuric acid to increase the electrical conductivity so that the electrolysis process will be better. So get back to our cases, okay. So for the color change, actually they have three main changes, okay, and we're going to illustrate that, okay, in two examples. So for the first case, okay, that will be the color will be from green to blue. Okay, what happened in it? Okay, so first of all, you have a look in the electrolytes, in the electrolytic cell. So if we just focus on the cathode, let's say this one is a cathode. Okay, cathode connected to a anode. Okay, sorry. Okay, so this one is anode, cathode, things like that. Okay, so what's happening around cathode? Okay, let's say, okay, if we have hydrogen ion discharge in the process. Okay, when hydrogen ion discharge, okay, become H2. Okay, we find one thing's happen. Okay, if H plus keep on leaving. Okay, then we'll have one thing's happen, because for the water, where is the H plus coming from? Actually, it's the water ionize itself to give H plus and OH minus. If all the H plus has left, okay, all the H plus has left, then you will find that we will have a lot of OH minus remain. So after this H plus remove, then around this electrode, we will then have a lot of OH minus remains behind. As OH minus represents the alkaline, okay, so you'll find that in this process, when you accumulate a lot of OH minus, the indicator will then change from green to blue. Okay, this one stands for alkaline. So due to the excess OH minus remains. Okay, so therefore remember, okay, if that place, okay, we're having H plus discharge become H2, then OH minus will then be remains. So in this case, okay, it will make the solutions turns blue. So how we write this explanation? So you can have a look here. So for the H plus ion discharge, H plus ion discharge, okay, the water continuous ionize, and then we'll have some excess OH minus ions left behind. So therefore, it will turn from green to blue. Okay, so remember three steps. First, H plus discharge, water continues to give H plus and OH minus. So therefore, excess OH minus remains. Okay, so these are the keywords that you're going to say. Okay, so H plus ion has prevented discharge, water continues ionize, leaving excess OH minus behind. Okay, so therefore it turns to blue. So same things happens, okay, if this time we are talking about the anode. If we are talking about the anode, okay, in the case like this one, okay, we'll find out we have Cl minus and OH minus in this case. So for here, we'll find that because it's a very dilute one, okay, so OH minus will discharge. If all the OH minus discharge, so OH minus will then become O2. Okay, and due to the water will continuous ionize, the OH minus discharge, and then you have excess H plus remains. So in this case, excess H plus remains, that means it will become acidic. So therefore, you will find that the color will show red in color. So that's why, okay, for the color, it will change from green to red, okay? Green to red, that means around the anode, you will see some red color appear here. While the other part, okay, you will see some blue color appear here. So this one is case 2, okay? So for the writing, more or less it's the same. Okay, you have to describe what things discharge first. Okay, hydrogen ion will discharge. Okay, and then the water continuously ionize. If you're afraid this statement is not clear enough, you may want to add water continuously ionize to give H plus and OH minus. Then that will be very, very clear. Okay, leaving excess H plus ion around the electrode, you have excess, leaving excess hydrogen ion, so therefore the color will then change from green to red. Okay, so this one will be the case 2. Last one, okay, that will be a little bit special. It's about green to red, then bleach. Okay, bleach means that it turned colorless. Okay, the indicator, okay, originally have color. After they bleach, okay, they will become colorless. Okay, remove the color of it. Okay, in this situations, okay, you have to refer to concentrated sodium chloride solutions. Okay, concentrated sodium chloride solutions, which you can find these examples on page 16 to 17 in the textbook. Okay, so for this one, okay, we'll find out we'll have H plus OH minus with Na plus and Cl minus. But one thing you have to remember, this one is concentrate. Okay, so therefore, due to the concentration effect, okay, Cl minus will discharge. Okay, so you will find that around it, okay, the Cl minus will then become Cl2. So one thing you have to remember, Cl2 is an acidic gas. And if you still remember the volume ratio issues, okay, the chlorine gas produced will redissolve in the solutions. So once the chlorine dissolve into the water, they will give out 2 kind of acid. One is hydrochloric acid. So obviously this one is acidic. Okay, the other one is hypochlorous acid. Okay, the name of it is called hypochlorous. Okay, but okay, when this acid ionized, they will give out an ion. This one's called hypochlorite ion, ITE. Okay, hypochlorite ion. Okay, so attentions have to pay to this ion. This ion, hypochlorite ion, is an active ingredient. Okay, it's an active ingredient. Active ingredient of bleach. With the HCl minus, okay, it can be a bleaching agent. It will then, okay, turn the color of the indicator to colorless. So that's why at the very beginning it will be starting from green, or the original color of indicator, first turn to red. Why it will be red? Because of these 2 things. Okay, because of both of them, they are acid. Okay, so therefore they will turn red, and then they will turn, and then the color will be bleach, because we got hypochlorite ion. Okay, so therefore the color around the solutions will first see that, okay, they will have some red color, and afterwards, okay, it will then turn into bleach. Okay, that means colorless again. Okay, so when you write this one, okay, you would like to say, okay, the chloride ion will discharge, forming chlorine gas. Oh, sorry, wrong spelling here. Okay, CHLORINE, chlorine gas. Okay, and then the chlorine gas produced will redissolve into the solution, forming HCl and HOCl. Okay, and you would like to remind that, oh, they are acidic, therefore will first turns to red. Okay, because HCl minus is a bleaching agent, and then it will then be bleached. Okay, so this is a little bit lengthy, okay, but the concept will be like this. Okay, remember reminding them they are going to have a HCl and HOCl, and then they will have an OCl minus, which is a bleaching agent. Okay, so the color will turn from red and bleach. So conclusion, okay, we've talked about 3 cases. Okay, one would be green to blue. Okay, because we will have H plus discharge, excess OH minus behind. Okay, so therefore it will turn to blue, while the other one is the OH minus discharge, excess H plus left behind, so therefore it will turn to red. And last one is the Cl minus becomes Cl2, so this one Cl2 will become HCl and HOCl. So first of all it will become red, and because of this one we'll then later on bleach the solution. Okay, that's all for this video. Bye bye.